Hi everyone, I am Usman Naseem and I am associated with the School of Computer Science at the University of Sydney, Australia. My research interest lies in the intersection of machine learning and natural language processing for social media and biomedical health informatics. And it's my pleasure to be joining you today at NLP Summit 2022 to talk to you about a pre-trained language model for public health surveillance on social media. So our agenda today will be, so first I will be briefly mentioning about what is public health surveillance, why social media for public health surveillance, followed by how we can mine a user generated text on social media using natural language processing. And then I will go a little bit deeper into pre-trained language models and we'll discuss the limitations of some state of the art pre-trained language model for tasks related to public health surveillance on social media. And then finally, I will talk about a new pre-trained language model that is designed for public health surveillance on social media. And then we will conclude with a very cool demo on how a new pre-trained language gives a better predictions compared to the state-of-the-art language model. So let's get started. So first thing is to know what is public health surveillance. World Health Organization defines it as continuous systematic collection, analysis, and interpretation of health-related data needed for the planning, implementation, and evaluation of public health practice. Historically, surveillance was mainly used to monitor infectious diseases. However, it can be used to monitor any health-related event such as chronic disease, injury, health service updates, or any environmental hazards. Surveillance can be thought of as the eyes and ears of public health. This health related information can be collected using many different ways. And these are divided into different types, such as some passive surveillance type is one of the type. Like it covers some methods such as registry related methods or health records. For example, in the registry, which is the collection of health data, a registry can have the data on birthdays, events, cancer, chronic disease, and variety of other diseases. And health record healthcare providers like hospitals also routinely collect data on the number of types of that seek environment. There is other type of surveillance is the active surveillance that includes the methods such as surveys or national stats to collect the data. These active surveillance is data is actively sought out. This type of surveillance is commonly used during the outbreaks. For example, during an outbreak, health teams may visit the community to actively seek out cases that may not have otherwise presented to the health centers. Health surveys are also a good example of actively seeking out health information. Survey can be done on community members, healthcare facilities, or entire countries. They can be done on as needed as well as or regularly basis. The other types of data collection for public health surveillance includes some research-based methods. This type of surveillance uses selected institutes or groups to provide health data on specific diseases or conditions. It can be used to monitoring trends and detecting outbreaks. But one of the very increasing useful surveillance tool nowadays is the social media, which will be focusing today. This relies on unofficial sources of informations like it covers blogs, internets, discussions, medias, and other social media types. Social media data can alert public health authorities to incidents or events that require further investigation and lead to the early detection of disease and outbreaks. Other data sources includes tools like ProMed, a website that puts together reports of disease events, or Global Public Health Intelligence, an internet-based early tool that uses the automated process. So for today's talk, we'll be focusing only on social media, but uh, So the next question is that what is the purpose of public health surveillance? So the purpose of the public health service is to assess the public health status, define public health priorities, evaluate programs, and to stimulate research. But how it can be used? It can be used, the information gained from the surveillance can be used for characterizing the patterns of disease detecting outbreaks, suggesting hypotheses for research investigations, identifying cases for further research, guiding disease control programs, setting public health priorities, or evaluation of health programs, and so on. So, since let's now talk about social media for public health surveillance. Um, Before we go into that one in more details, we need to know social media. All of know that there is a enormous number of users. It has a huge database like Twitter and Facebook. The number of users are increasing every day. It's a source from which people's opinions, ideas, and experience can be directly accessed. We have specialized social networks. Massive amount of data are being generated, and everything is on real time. So we have a very huge amount of useful data which we can mine for better interventions. But why social media for public health surveillance, right? Because um, large volumes of data being constantly added, large component of its language based, effective approach is required to convert raw data to information and information to the knowledge. And this information, this huge amount of data is only useful if it is transformed to the knowledge. So as main component of the social media data is text, so we need to find out some better ways of how to model this language. So, but who is social media user, right? Uh, a diverse audience of more and more people each year. Just look at at these statistics. You can see here in the first figure on top right that number of US adults who said they use at least one social media is increasing every year. Similarly, there was another study by the researchers from Penn universities. They mentioned that uh, heart diseases rates as reported on death certificates and the one which are predicted by Twitter, they look similar. So they can mine. They reported that we can mine the social media data to predict the heart diseases. So a user-generated text on social media enables health workers to keep track of information, identify possible outbreaks, forecast disease trends, monitor emergency cases, and ascertain disease awareness, and response to official health correspondence. This exchange of health information on social media has been regarded as an attempt to enhance public health surveillance. Examples of social media public health surveillance include social media posts, especially in case of Twitter, the health tweets, which gathers down from Twitter. Twitter data is considered highly useful for health research as its data policies allow public access to 1% of raw tweets. Tweets can also be geolocated, which can be used to model the spread of disease. It is also most used social media platform public health surveillance. During the COVID-19 pandemic, Facebook used aggregated anonymized data collected from its platforms to provide human movement to disease models. So all these comes with the challenge since as we are talking about the textual data. So the textual data is highly specifically for the social media is very unstructured, and there are some challenges with it. So let's talk about now some challenges. Human languages are messy, ambiguous, and ever changing. We as a human, because of our prior knowledge, can understand the knowledge. We understand different ambiguities. We understand the different short words. For example, if we look at these tweets, All of these tweets, people are mentioning about their health conditions. In the first, I have headache, some uh, phase which reflects the user's feelings about bad feelings. This cough I got hurt so bad and got the maddest migraine with the sad face. So all these information, people are talking about their health conditions on social media, and they are also adding some their expression, their emotions, which we can understand as a human because of our prior knowledge. And also, if you look at this right image, like apple, right? So for instance, I am eating an apple, I have an Apple iPhone. So we as a human being can understand that both of these apples, the context of this word apple is different. But what about the machines? We need to train the machines to understand the context. And in the last, as I mentioned, that the data on social media is highly unstructured, is noisy. We know from our knowledge that LOL stands for laugh out loud, G2G stands for got to go, and so on. But machine doesn't know these things. We need to train the machines to understand and communicate like humans. This is our goal. So so what we need methods that can understand the context like humans. And but the question is that how can we model the language like humans? So the answer of this question is in the language modeling. So what is language modeling? um, okay, so, language modeling. A language model captures the probability of the sequence of words in the language, as shown in the above image. The cat sat on the mat. It has the probability of each the next words, and then the next word is selected based on the probability. So that's how the language model captures the sequence of words, and this is how the basis of the language modeling. So let's talk about briefly on the history of language models. So I will not go into deeper details, but I will just quickly go through this one until we talk about these pre-trained language models. Started in early 2000s. The one of the early breakthrough was in 2013, which was word embeddings. The famous ones are word2vec, glove, and fast text embeddings. You might have used those already in your tasks, but all of these word embeddings does not capture the context. So the efforts continued until the major breakthrough of pre-trained language models in 2018. So the latest pre-trained language models are the latest major innovation in the world of natural language processing. Is undoubtedly the large pre-trained language models. So pre-trained language models embeddings can be used as features, or pre-trained language models can be fine-tuned on a target task data. The main advantage of these pre-trained language models comes from the ability to learn word representations from large unannotated text data, which is particularly beneficial for low resource languages when label data is scarce. The other question is how to train a language model. To train a language model, we need a task on which the model has to learn. One task is to predict a model given its surrounding words, or predict the surrounding words given the current word, like we saw in the example of the cat sat on the mat. In fact, these two language models were used when creating word2vec embeddings. Training and language model in this manner is called pre-training. So once we have this language modeling architecture, which is phase one, semi-supervised learning, we train it on the huge corpus, and then we get the pre-trained model, which is in the phase one. In the phase two, we can do some downstream task fine-tuning. So whatever is our task-specific data, we can always fine-tune it to get more better performance. However, we can always do the transfer learning, but sometimes it doesn't work well. So fine tuning gives us the better performance when we have some domain specific task or any specific task of these pre-trained language models. So a pre-trained language model can be applied to a variety of natural language processing tasks. However, since each task is different, we do task specific fine tuning of language model. So Pre-trained language models. So among the well-known natural language models, pre-trained language models are this ELMO, this is embedding from language models, ULM fit, we have BERT, GPT, GPT-2. BERT is was introduced by Google. In particularly has many different variants such as Roberta, Albert, Tiny Bird, Distil Bird, and many more. But as I mentioned earlier, BERT is actually uh, uses the architecture of transformer, and we have two variants available of the BERT, which is BERT base, which has two layers of transformer encoders, and BERT large, which uses 24 layers of the transformers. BERT is pre-trained on two natural language models, like as showed earlier in the stage one, which is semi-supervised learning, on masked language models where they mask 15% of the data to predict the next word and next sentence prediction for the tasks that require understanding of the relationship between sentences. So two stages. The first one is semi-supervised step for pre-training a language model, and they used the Wikipedia and the book corpus to train the model, and that resulted in the BERT pre-trained language models. And then in the stage two, which is supervised learning step, where they fine-tune the model again on a task-specific data for different downstream tasks. So that is about BERT, but there are some limitations of a BERT. And say that um, BERT has limitations, and it may introduce some errors and lead to flawed conclusions. For example, in this example, we have a tweet. A group of kids is called migraine, where this is taken from the social media, from the tweet, one of the tweet for by the social media user. So we can see that the word migraine is used here by a social media user to not to talk about his personal condition, but is being used as a figurative language, not in the real meaning, so not in the literal meaning of the migraine, right? So BERT predicted this label as a personal health mention, whereas the correct label for this tweet is figurative health mention. In another example, I want to show you like whole nation was affected by Kabali fever. Here, the fever word is not used to discuss the health condition of a user, and the same thing happening here. The Bird product predicted this as a health mention, and the correct one is a figurative health mention. At the end, I will show you a demo how we can Bird predicts the wrong one on these examples, and how which model can predict it correctly. So what we did, we probed 50 social media posts where the users some health related tweets, and we tested using the BERT pre-trained model, and we found that 80% of the predictions by BERT were wrong, and only 20% were correct. So that leads to that highlights that what is the limitation of the pre-trained language models, which are trained on general languages and general corpus such as Wikipedia and book corpus. And this kind of things, this may introduce errors and lead to some flawed conclusions that could overrepresent the importance of certain health issues by location or over time, and lead to poor quality make decisions making about policy or resource allocation. So the question is that now what is the solution if the current state of the art language models is not performing well for the task related to public health surveillance on social media? So how we can do it? What is the solution? So the solution is PHS BERT, which is a domain specific pre-trained language model for public health surveillance, especially designed for the tasks related to health surveillance on social media. And PHS BERT, I'm proud to say that is one of the pre-trained language model which I did during my research, and it is publicly available and has been adopted by many companies for their tasks related to health surveillance. So what we did here, we mentioned that since uh, the social media data of where people are using some different disease and symptom words, they are talking about their health related health conditions. We that's why we need a domain specific data corpus to train the model on particular one. So Wikipedia or the book corpus, they do not, they might represent but not as 100% as social media data. So what we did, we collected a large amount of data from Twitter using some keywords related to health, and we pre-trained the BERT again using the same semi-supervised learning steps, and in as a result we got PHS BERT. This PHS BERT is trained on social media data, and it has the domain specific knowledge, right? So that's why we call, and it has been tested on, especially designed for the tasks related to public health surveillance. And it's as I mentioned, so our objective is the same. We predict the mask wording similar the way the BERT has done. Our data set was, we use the weights of BERT, which has already information of Wikipedia and book corpus, and then we augmented it with our own data collected, and then when we pre-trained it using semi-supervised learning step. So as a result, we got PHS BERT, and then we performed one of the largest study on the task related to public health surveillance. This is the figure from the paper. The link of the paper is given below. So we have, as I mentioned, we initialized the weights from the BERT and then added our own new data, collected data that resulted in the PHS BERT. And then during in the stage two or the fine tuning, we tested on 7 different public health service related tasks. Those tasks includes public health mentions, vaccine related sentiments, some mental health issues like stress, depression, suicide, COVID, and other health related data sets. So we tested it on about 25 data sets from very different social media platforms such as Twitter and Reddit as well. And we found that this outperformed, the PH BERT outperforms the BERT, which is the current state of the art language models, on all of these data sets by a huge margin. So let's have a look at the demo of PHS BERT. So okay, so the link is given here. I have also included the link in my slides. So the first task is for vaccine sentiment classification, where we have add some tweet to find out whether to find out whether it is vaccine critical, neutral, or vaccine supportive related to it. So let's try this one. So vaccines are bad. We know as a human being that this is negative or something about vaccine critical. So let's submit and let's see what is the prediction. So you can see here that the state of the art, which is BERT, it predicts as a supportive, which is wrong, and PHS BERT predicts is as vaccine critical. So let's look into another example related to vaccines. The vaccines today are so dangerous and obviously worthless. So this is again something negative about vaccines. So let's see again. So the BERT predicts as a supportive, which is wrong, and PHS BERT predicts is rightly. Yeah. So now let's move to the next task, which is health mention classification task. So let's take the examples we discussed in our presentation. So a group of kids is called a migraine. So let's try to find out the predictions, right? This is not talking about the health condition, it's talking about something figuratively, right? So it says that it's a non-health mention, but Petersburg predicts correctly and says this is a figurative usage of disease ones. And there are some different tasks, some COVID related, some stress, adverse drug reaction tasks. You guys can always go and try to select from the examples, and see what is the prediction. For example, in this one, I'm not massively worried about because it feels good. there is no stress, and but the bird predicts it as a stress, right? So please feel free to play with it and find out where the PHS bird works better compared to the state of the art bird. And you can also look at the John Snow Labs that in the NLP models, PHS Bird has 8 different variations for different tasks such as depression, and also for public health mentions. So please, vaccines one, and feel free to go and download and do it for different tasks you want to try. So let's go back and. Yeah, so as I mentioned, it's also publicly available on GitHub, and the link is given for the demonstration. So feel free to contact me if you guys have any questions related to PHS Bird or anything related to natural language processing for health. You have my Twitter, LinkedIn, email, and my bio page. So thank you very much for your time, and good luck with the rest of the conference. Thanks.